Right dog, please.
To the uninitiated, all hot dogs look pretty much the same. But in truth, all hot dogs are not created equal.
First you have an all-beef Frankfurt. Then you have a meat Frankfurt, which can be pork and beef. And then you have a third type that also can include chicken.
Sidney Schiffman is a hot dog scientist. In a matter of minutes, he and his associates can produce numbers that reveal the true essence of any hot dog. They bake the hot dogs and weigh the remaining ash to determine the water content. They dissolve hot dogs in acid and measure the amount of fat that rises to the top.
The reading gives us a direct determination of the fat content of the sample with which we're working.
Combining all the data gives them a single important number, the calorie content of each hot dog. It turns out that behind their similar appearances, hot dogs vary widely in their calorie content. In this unit, we're going to learn a way to describe such variations in a data set in a new way. The calorie data produced in the hot dog laboratory are valuable for consumers who want to have their health and their hot dogs too. Here are the results of the tests of 20 brands of beef hot dogs. For a good overview of this distribution, we need a picture. Since we have only 20 observations, we prefer a stem plot rather than a histogram. There's quite a large range in the calorie content, from 111 in the lowest brand to 190 in the highest two. We can see that the distribution is a bit irregular, with two small gaps. It's fairly common for small sets of data to have irregular distributions. Now let's describe the distribution numerically. We'll use the median to tell us the calorie content of a typical beef hot dog. Since we have 20 brands, the location of the median is 20 plus 1 divided by 2, which equals 10.5. That's halfway between the 10th and 11th hot dog in the ordered list. The stem plot already arranges the data in order. That's an advantage of stem plots. But we'll write the ordered values here for easier viewing. The 10th and 11th values are 152 and 153. So the median is the average of these values, or 152.5 calories. Knowing the center of a distribution like this is a good start. But to really understand the data, we need to know something about the spread of the data as well. The smallest and largest values help show this. They're often called the minimum and maximum values. But looking at just these two values isn't enough. The lowest value, 111 for instance, lies quite a bit below the next smallest value, and so it doesn't tell us much about the distribution as a whole. To get a fuller picture of the spread, we can find the points in the distribution that are 1/4 and 3/4 up the list. These points are called, logically enough, quartiles. The quartiles are found in a way similar to that used to find the median. The 1/4 point is the center of the observations between the minimum value and the median. So we'll find the median of this part of the distribution. That'll be the first quartile. Doing the same thing for the upper half of the distribution will give us the third quartile. The second quartile, by the way, is the median itself. So let's find the quartiles of our hot dog distribution. We found that the median fell here, midway between the 152 and 153 values. So these 10 values lie below the location of the median. The first quartile is the median of these 10 observations. That's midway between the 5th and 6th value, or 140. The third quartile is just the median of these 10 observations. Once again, this is the average of the 5th and 6th values, or 178.5. The median and the quartiles, together with the smallest and largest observations, give a compact description of the distribution. The median marks the center. The quartiles contain between them the middle half of the data. The two extremes show how far out the data extend. These 5 numbers are called the 5-number summary of the distribution. Let's take a look at another distribution and break it into quartiles to be certain we understand how it all works. The calories of all meat hot dogs, which are hot dogs with a variety of meats in them, were also measured. Using our recipe for finding the median, we find that since there are 17 observations, the median is the 9th value in the list, In other words, the median calorie level of all meat hot dogs is 153. For the 20 beef hot dog brands we looked at earlier, the median was midway between two observations. Here, the median falls right on one of the observations. The data points lying below the median are these, leaving out the median point itself. The first quartile is the median of these 8, or 138.5. These 8 points lie above the median, so the third quartile is their median, or 180.5. So the 5-number summary for calorie counts in meat franks, the minimum and maximum observations, and the 3 quartiles, is 107, 138.5, 153, 180.5, and 195. These 5 numbers give us an excellent short description of several important aspects of a distribution. The median marks the center. The quartiles catch the central half of the data between them, so the distance between the quartiles indicates the spread of the central part of the distribution. Like the median, the quartiles have the advantage that they are not changed by a few outlying observations. And finally, the 2 extreme values show how far the distribution extends in each direction. So the 5-number summary describes center, spread, and gives an indication of symmetry or skewness. Not bad for 5 numbers. In statistics, the best description of data often combines the precision of numbers with the clarity of pictures. The 5-number summary leads directly to a very handy way to picture a distribution called a box plot. Here's a box plot of the calorie counts for all beef hot dogs. First, we create a scale marked off in calories. Now we add a box with ends at the first and third quartiles. This box spans the central half of the observations. Mark the median with a line inside the box. Finally, extend whiskers at each end of the box up to the largest single observation and down to the smallest. A box plot is thus just the 5-number summary in a picture. How do box plots compare with stem plots and histograms as graphical descriptions of a distribution? Well, box plots don't present the distribution in the detail provided by a stem plot or histogram. You can see this when you compare the box plot of the all-beef hot dogs with the stem plot we made earlier. The stem plot reveals 2 clusters of data with a gap between them, and the outlier at 111 calories. And of course, the stem plot actually shows the value of each data point. The box plot doesn't show such detail and doesn't show clusters and outliers. What box plots are good for is a quick comparison of several similar distributions. For instance, here are box plots for 2 other kinds of hot dogs, all meat and chicken. We can see at once that there is little difference in the distribution of calories for beef and meat hot dogs, but that poultry franks as a group have markedly fewer calories.